guys, and welcome again to Miss B's virtual classroom. As you can see, I got a board that no longer will fall down on me. But anyways, what I wanted to talk to you about today is we're doing lesson 8.4. And the lesson objective is to describe a sequence of transformations that map one figure onto another to determine whether two figures are congruent by using a sequence of transformation. So remember, all of our transformations are either a reflection, a rotation, a translation, or a dilation. Those are the ones we have learned so far. So today we're going to take a look at, can I flip each of these figures around? And are they congruent by doing a series of transformations? And if so, are they similar? Alright, so let's take a look first at this one. This is example 1 on your notes, so you can follow along. As you can see, remember that our original figure is always going to be denoted with just a letter. So for example, Q. So I know that this is our pre-image. This is the image that we have before we do anything to it. Alright, that's this bad boy right here. If I'm looking at my pre-image, then I know certain things about it. So I can look, and the first thing I want to do is I want to look at the points. Q is at -2, 1. R is at -6, 1. Oh, I'm sorry. Miss B is doing what I yell at you guys for. This is 1, -2, and this is 1, -6. This one is 6, -6. And then P is at 4, -2. Alright, so if I'm looking at these points here, I'm going to then look at my image. Remember, what comes afterwards is our image. And this is kind of confusing because this is an image and a pre-image. But we'll just think of it as an image for now. How did I get from here to here? So I don't even want you looking necessarily at this one. Well, was it a reflection over the x-axis? No. It's not getting any bigger because this is 1, 2, 3, 4 units down. 1, 2, 3, 4. So it's not a dilation. It's not a reflection. It wasn't rotated because it's still the same. It's not reversed. So that leaves me with a translation. And remember, that's a slide. You can see either slide up, slide down, slide right, or left. Because these are in line with each other, I'm going to say it's just a vertical translation. So I'm going to count up from Q how many. So remember, Miss B uses 2 little squares to represent 1 as opposed to on your graph. So look with me. 1, 2, 3, 4, 5, 6, 7. So I moved my figure up 7. Up 7 units. Alright, so that was our first translation. So I can say that our first translation of 7 units up, alright, up, and 7 are our key things, onto our image, which was Q prime, P prime, it's important to list the letters in alphabetical order. So onto P prime, Q prime, R prime, and S prime. Okay? So that was our first transformation that we did. Alright, so now this is no longer the image, but our pre-image for the second one. We can actually create images after images after images by how many little apostrophes we have after. So a P with 1 apostrophe means we did 1. And 1 with 2 is 2, 3, 3, 4, 4, so on and so forth. Okay? So keep that in mind. Alright, now I'm going to look at how, I'm going to ignore this one. How did this one change? Well, because it's not a dilation, again, it's the same size. We can see that because they're on the same horizontal levels. It was not rotation. It was not a dilation. It didn't shrink. It wasn't a transformation because that would be a slide and it doesn't directly. So I'm left with a reflection. So if I look at it, because I'm going from here to here, I know that it is a y-axis reflection. So I know that it has gone from here to here. It's like I took it and it's the mirror image and I flipped it. And that created prime, prime. So a reflection, so there was then a reflection, all right, that occurred over the y-axis, all right, to make or to map onto P prime prime, Q prime prime, R prime prime, S prime prime. So that's what occurred here. All right, so if I put this all together, I would say that, so a translation of 7 units up, okay, 7 units up, followed by a y-axis reflection is how I end up with our P prime prime, Q prime prime, R prime prime, S prime prime. Does that make sense? I hope it does. So it's just keeping in mind, all right, what am I, oh, and let me move this back so you can get it all. What am I doing to make the image, the original image or pre-image into this new image? Okay, so these trapezoids are actually then congruent. Okay, so let me grab an eraser. All right, and let's do a quick check. All right, so if I erase this, all right, and I'm going to take a look at my second example, which I'm going to hang up here. All right, oops, and it got a little messed up, so I'm going to have to fix it for us. Okay, so here is our quick check. All right, and if I'm looking at it here, I see now that we're going to be calling this image over here our pre-image. This is where it is starting. All right, so if I'm here with my pre-image, again, I'm going to see how am I moving my trapezoid so that it lands on top of the other. So I'm going to take my pre-image and I'm going to look at my image to see what happens. So take 30 seconds and decide what you think it is. All right, good. You are absolutely right that it was a y-axis reflection. How do I know this? Well, that's a great question. If I'm looking at this here, I'm going to say, all right, nothing really changes. My y and z are on the same playing field, so nothing was rotated. Because it's a trapezoid, I know it wasn't a slide. And my x's are kind of next to each other. So that kind of gives the hint it was a reflection because they're next to each other. If it was a translation, which is a slide, my w and x would, my x would be over here, my w would be here. A little kind of crazy talk. But you should have been able to recognize that it was a reflection. And since it was a reflection that went from here to here, I know that it was a y-axis reflection this way, okay? So this is our y-axis, and this is the reflection it made. So I'm going to first say it was a reflection over the y-axis, okay? All right, now you have to look at how did we get from this image to this image. So here's our pre-image and here's our image. Well, Was it a rotation? No. Was it a reflection? No, because then my short side of the trapezoid would be down here. Was it a dilation? Let's count our units. It's 1, 2, 3. Okay. 1, 2, 3. Nope, it's the same. So we know that it was a translation. It shifted down. So we have to count the units. So we start here and we go 1, 2, 3, 4, 5, 6, 7. All right. But this time we went down 7 units. All right. So to finish off my statement for the quick check, I would say it's a reflection over the y-axis followed by a translation of 7 units down. And these figures are congruent because we didn't do any dilation, so we didn't do any manipulations. Hopefully that answers all your questions. We're going to move on to video 1, but move on to video 2, and this is the end of video 1.